All right, we're going to do a third question on optimization. Okay, so we want a 4-liter container that has to have a square base and the vertical sides, and this container is open to the top, kind of like our cake tin that we had the other day. So if it opens up, we're going to have something like this. Okay, so find the most economical shape that minimizes the surface area that's needed. Okay, so here we've got our shape here, and this is a square. So I'm going to call that x and call that x, and then it's got a height of y. Okay, so we want to have a volume of 4 liters. So first of all, 1 liter by definition is equal to 1,000 centimeters cubed. So we have to start off with that. So our volume formula is length times width times height, right? So x times y. So the volume is equal to x squared times the height, which I'm calling it y. Okay, so and we know this volume is going to be this volume is 4 liters, isn't it? So I can say 4,000 centimeters cubed is equal to x squared y. And what I'm going to do now is I'm going to solve for y, and then we get y equals 4,000 over x squared, and we'll be using that just in a minute. Okay, now we're going to talk about the surface area. So surface area is going to be, so what happens if I open up this box? So if I open up this box, okay, so I unfold it. I've got these sides here that I'm marking in red are all the length of y, right? And the bottom base is a square, right? So these lengths here are x. So we have all 5 of these quadrilaterals in here. So this green area is x squared, and because this is x times x, right? X times x gives me this x squared. And then the area here is x times y. So, and how many of these rectangles I have is 4, right? So 4 times x, y. Okay. Now, what I'm going to do now is I want this all in one variable. I'm going to replace y with 4,000 over x squared. So now my equation becomes SA equals x squared plus 4 times x times 4,000 over x squared. Okay, think about that for a minute. Okay, and then, so now let's multiply that out. My surface area is x squared plus, okay, 4 times 4, that's going to give me 16,000, and x in the numerator and x squared in the denominator, that's going to give me a single x in the denominator. I'm going to write it like this. Okay, so now in order to find the minimum surface area, I need to to find the minimum surface area, we need the derivative of this equation to be 0. Okay, so let's find the derivative. Okay, so ds dx is equal to 2x. The power gets multiplied by that, so negative 16,000 times x to the negative 2. And if I type that into my calculator, so I've got 2x, I've already typed it in. There we go. So the next thing I'm going to do is I'm going to hit graph, and then we get something like this. Okay. You might need to change the window around. The y values aren't as important as the x values because we want to see where it crosses the x-axis. So here I've got negative 10 and 50 when you hit window, and I changed this around. So here's my graph. I'm going to just draw this in my notes so you see what the picture of the graph looks like. It was like okay, something like that. Okay, see. Now, we want to find where it intersects right here, the 0. So to find the 0, I hit second trace. And then I'm going to hit 2 for 0. And then it says left bound, so I'm going to hit the left arrow till I get left of the intersection here. And I'm going to hit enter. And then it says right bound, so I'm going to hit the right arrow until I get to the right side here. And then I'm going, and then I hit enter. And then it says guess, and I hit enter. And then it's going to say that x equals 20. And the units of this is centimeters, right? Okay, and if I want to do a sign diagram, that might help me figure things out here. Because if I do a sign diagram, then we know at 20, to the left of 20, I've got negative values here, so it's negative. To the right, so this here is 20, right? To the right of 20, I've got positive values. So remember, this is the graph of the derivative. So if the slope is going down and then it's going up, we know that we've got, if the slope is going down and we know it's going up, then we know we've got a minimum. Okay, and which is what we're trying to figure out. We're trying to find the minimum surface area. So we know that the length of x is 20. So since we know here's my box, right? Okay, on the previous page, we said that y equals 4,000 over x squared, and we just said x equals 20, right? So we can say that the height y is going to be equal to 4,000 divided by 20 squared. So So 20 squared is 400. So 4,000 divided by 400 is going to give me 10, right? So the most economical shape of the box is 20 by 20 with height 10 centimeters. Don't forget the units. Okay, so 20 by 20 by 10. And I hope this extra example was helpful to you.